Capacitance detection and measurement. In this class, we will look at how we can measure capacitance or in specific parallel plate capacitance and use it for various applications. Capacitance is the ability to store energy in an electric field. Between the two parallel plate capacitors shown in this graphic, on this orange plate and the purple plate, consider these two to be the parallel plate capacitance. Any object that you place inside with having a relative permittivity of epsilon r acts as a dielectric, and that changes the performance of the capacitance. It either increases the capacitivity or decreases depending upon how it is, and it is governed by this equation of the capacitance given as capacitance equal to epsilon naught epsilon r into area, surface area of the plate PPC, divided by the distance between the two plates. So what does capacitance essentially do? It holds the charge Q in this plate when we apply a voltage across the parallel plate capacitor, which is V. So when you apply a voltage across the metals, you get a field. Electric field is generated in the direction of that voltage supply from positive to the negative terminals, and charge is held within them. So to enable that, so this is how a material can be used. Now, this material which can be placed here, epsilon r, okay, so that material can be the sensing element. So that enhance, in essence, the device placed within this blocks becomes your capacitance sensor. So you can measure rate of change or absolute change of capacitance using this epsilon er. And how do you do that? You have a capacitance to digital converter called a CDC, which is controlled both directions using either a host system, which could be a microcontroller or any data processor, using the serial interface protocol called I2C or SPI, serial peripheral interface. Okay, so this is what it does. So these two will initiate a transition, and a CDC will provide an excitation voltage, meaning it will apply a voltage supply to this difference of these plates. Now the difference of these plates will conduct or have the field will trap some amount of charge and becoming your capacitance effectively, and that response either as a voltage goes back again to the CDC, not as a charge, but the charge when converted into current, converted into voltage, will go back to the CDC, which the CDC will again convert and give it back. So this is the capacitance detection method, and the measurement is done using a capacitance to digital converter, which we will see in the next class.